Welcome to a lesson with Dr. Powell. Let's take a look at how we can take two vectors in 3 dimensions and consider a triangle made from them. But one of the vectors we'll consider as being kind of representing like a ramp or something we're projecting onto. Okay, so we're going to study this right triangle where one of the vectors is in line with this, but we're not going to be so concerned with its length and how long it is. Okay, so let's just suppose we have two such vectors. Suppose we have 2, 1, and -1, and maybe we have 1 comma -1 and maybe 5. Okay, so maybe this one is a little bit longer than that. But however it works, we just put the two vectors down, and the arithmetic's gonna tell us exactly where things are gonna be located. This vector right here is too long. We'd like it to be a unit vector to really effectively work with so that multiplication by quaternions or cross product and dot product that comes from it can actually behave nicely and just refer to rotation. So we need to make this into a unit vector. We do that by dividing it by its length. So its length is simply 1 squared plus 1 squared plus 5 squared square rooted. So that would be square root of 27. Okay, so we're going to take this guy right here, that over that, and that's going to help us rotate things around. Now, if we take a dot product of this with that, that actually gives us the projection. So the projection length from here to here. So we can just do that. We can take a dot product, and these are lined up very nicely the way it is vertically here. So we can just think that 2 times 1 is 2, 1 times -1 is -1, -1 times 5 is -5. And notice the whole time, I'm dividing by -27, so I'll have that out here. And then it's just multiplied to that. This is the dot product added together. Have to add this. Dot product is a number, not a vector. So 2 minus 1 minus 5, which would be -4. So we're going to get -4 over square root of 27. Notice how this projection is negative. That's because in reality, what's going on here? This picture is inaccurate. So we have to modify it a little bit. Really, the vector is going this way. So 2, 1, -1 is facing that way from the other one, so that the projection is a negative value right here. Okay, so that's projection. Now, what about this length right here? How would we get that? That's the imaginary part in the rotation, meaning just the cross product. So you take the cross product of these two guys. Now, cross product is actually easy to see, even just having the vectors lined up like this, except maybe we want to line them up the other way, because the first vector is the vector that represents the ramp here, or what we're projecting onto. So I'll write out 1, -1, 5 first. That's what we're going on to, and then the 2, 1, -1. Okay, now to get the cross product, it's going to have an I, J, and a K in it, and I can just visually see what's going on right here. So using one of the techniques, I can just do this. I can just take these diagonals as written. 1 minus 5, that's -4. I'm done with that. Okay, then for J, I can go right here, 1 and -1, so that's -1, and minus 10, so it's -11. Let's change the sign because it's J, so +11. For K, I get 1 minus a -2, so that's 1 plus 2, so that's 3 plus 3. Okay, so that is the cross product. So how do you find the length of that triangle right there? You just take the length of this. So the length of that, which I guess is right here in the better picture, would be you take the square root of the sum of the squares. So you get 16 plus 121 plus 9. So we get 130 plus 16, so 146. Square root of 146 would be the length of would be that length. If that was done accurately. Let me double check that. I think so. Oh, that's right. It was done accurately. But remember that we're dividing by the square root of 27. Okay, so that makes the lengths look a little bit nicer. Okay, divide by the square root of 27. And we actually get what we're after, right? Because I didn't divide. Okay, take cross product, but then remember to divide out one of these vectors by that, and that'll just be like dividing the result by square root of 27. So really, this is the result right here. Square root of 146 divided by the square root of 127, and that would give you that perpendicular length. So we've just studied that triangle. How would you find this angle? Well, you have these two lengths. Just do some trig. Take an inverse tangent. You can even find this length right here. You can do a cosine with that. Play with it. It's all there because you have your lengths. Thanks for watching.